All right, so this unit is on sequences, and so sequences are patterns, and we're going to just kind of talk about today two types of sequences. Each number in the sequence is considered a term, and a finite sequence is a sequence that has an ending, and an infinite sequence is one that continues on. And usually you can tell the differences. These are going to have your numbers, and then it's going to have your ending bracket, where these ones are going to have your numbers, but then it's going to give you some dots to show this is going to continue. And so it doesn't have an end. So there's two main sequences we'll talk about. Arithmetics is when they have a common number that we add or subtract. So it's adding and subtracting, same number every time. So that's considered arithmetic sequence. It has a common difference is the number that it's going up by. And then we'll talk about geometric sequences, that is multiplying or dividing. So you have a common ratio. So we multiply or divide by the same number. So here we describe sequences. So sequence domain is the natural numbers 1, 2, 3. So the first term in the sequence is 1. So this would, if I was looking at the ordered pair, it'd be 1, 3. Second term is 6, 9, 12. And notice this is finite because it ends. This is infinite because it continues. So we're determining whether this is arithmetic. So remember, arithmetic is that we're adding or subtracting the same number. So if I look at here, it's going down 5. This one's going down 5, so we're looking pretty good. But this one's going down 10. So since these are not all the same, it is not arithmetic. It doesn't mean that it's not a sequence. It's just not an arithmetic sequence, so it's not going to have a steady amount. Okay, here we're going up by 6. This one's also going up by 6, and this one's going by 6. So by what we see that these all have the same common difference of 6. So yes, it's arithmetic. Common difference is 6. Right, so that gives you a good example of arithmetic. Let's look at arithmetics just a little bit more. So once we know that it's arithmetics, we can then determine what the next numbers are. So we have -8, -6, -4. So we know this is arithmetic, so it has a common difference. This is going up by 2. Up by 2, so the next one's also going to go up by 2. So if I add 2 to -4, I get -2. We're looking at the next 4. Add 2, get 0. Add 2, get 2. Add 2, get 4. So my next 4 terms are these 4. If I look at the graph of those, so we have these terms that we've just decided. So we're going to graph all 7 of them. So this graph for this point would be 1, -8. So that would be that point. This is term 2, so this would be 2, -6. And this is term 3, so it'd be 3, -4, and so forth. So when I'm graphing these, here, the first one was 1, -8. Next one is 2, -6. So 2 down 6. Then 3, -4. 4, we'll keep going. 4, negative 2, we're going to graph all of those. 5, 0. 6, 2. And 7, 4. So looking at these, notice that these are all linear. So arithmetic sequences are linear. That's going to be key as we continue to study these. So like I said, that graph of the arithmetic was linear. It's kind of my PowerPoint shut down. So sorry about that. We will go ahead and look at another one here. So here we know this is arithmetic, so we know that they're going up by a common difference. And we look at this and it's going up by, so to figure out what is going up, you can just take two of them. And we see that it's going up by 9. So we're going to keep going up. So if I add 9 to this, I would get 5, and then add 9, I get 14, and add 9, and I get 23, and so forth. So we see that that's the next 4 terms. So first term was negative 22. Negative 22 plus 9 is negative 13, and so forth. So first term, negative 22. Second term, negative 13. So we want to find the graph that goes with that. So we had first negative 13. Then third term is negative 4. And so forth. And you'll see that that just continues to keep going up. Alright, so since we know it's linear, then we can also find any parts in there. So during their routine, a high school marching band marches in rows. 1 performer in the first row. So my first term is 1. There is 3 performers in the next, and 5 in the third, and it's going to keep going. So we notice they're going up by 2s. They want to know how many is in the 20th term, so we can find that common difference is 2, so that's also our slope. So if we have the points 1, 1, and we'll just take a couple points and we'll find an equation, and we have the 0.35. So we could keep going till we get to the 20th, or like I said, we can find our slope. So we have our slope is 5 minus 1 over 3 minus 1, which is 4 over 2, which equals 2. So my slope is 2. So I can use a point, find a point. So y minus 5 equals our slope, 2. X minus 3, where x is my term and y is the number of terms, or the number in that row. So y equals, distribute this out, 2x minus 6, and we're going to add that 5 over plus 5. So y equals 2x minus 1. And then we can go ahead and plug in 20 to find what the number would be in the 20th row. So 2 times 20 minus 1. So 40 minus 1, which equals 39. So we know that there'll be 39 in the 20th row. So here's another example of that. And let's go back now to geometric. Geometric, we're multiplying by the same number, so it'd be the same ratio between there. So it doesn't have to be by a whole number. So 20 over 8 should equal 50 over 20. If I reduce that, I get 4 goes into here 5 times, 4 goes in here twice. And this also equals 5 over 2, and we're going to go one more. So 125 over 50 should also equal that same thing. 25 goes into here 5 times, and 25 goes in there twice. So we see that they all have the common ratio of 5/2. So yes, it's geometric, and our common ratio is 5/2. So if I multiply this by 5/2, I get 20 and so forth. So we'll try this again. So 30 over 19, does that equal 41 over 30? And we see that it doesn't, so this is not geometric. And what we're going to find is, so I'm going to go ahead and go that one, what is geometric, is that same thing. Once we figure out what our ratio is, we can continue to keep that terms up. So I can take, this is geometric, so I can find my ratio by going 15 over 10, which equals 3/2 or 1.5. So I'm going to take 22.5 times 1.5 to find the next one. Gives me 33.75, and then I'm going to continue. Next one would be 50.625, and then keep multiplying by 1.5. Next one would be 75.9375, and you could keep going. So these are my 6 terms. So then if I graph these, what we're going to find is that they are, here's my term numbers, here's my what I get. So when I look at them on a graph, I'm going to go up by 5s. Probably should have gone up by 10s. Let's go ahead and do that. So first term was 10, second term was 15, third term was 22.5, fourth term is 33.75, fifth term is 50.625, sixth term is 75. So you kind of see this curve here, and that's going to show you that this is exponential. Right, so then the last part is determining whether it's arithmetic or geometric, so you're checking each one or neither. So first let's check and see if it's arithmetic by seeing how much we're going up by. So here we're going up by 12, here we're going up by 12, here we're going up by 12. So since we're adding the same number, this would be arithmetic. Common difference is adding plus 12 is I'm going to use that as my reasoning. So here, if I look at this, it goes plus 3, plus 4, plus 5. So it's not arithmetic. If I take my, try my ratio, 5 divided by 2, does that equal 9 over 5? No. So that's not equal. So it is neither. Does it have a common difference or a common ratio? Okay, this one goes down, negative 18. For this, between these, minus 18 plus 36. So it's not not arithmetic. So then we look at the ratio. Negative 12 divided by 6 is negative 2. 24 divided by negative 12 is negative 2.